Okay, hey everybody, I had a great idea I wanted to share with you. So let's talk about relative humidity and how it compares to moisture content. This is a real quick example. Let's say, for instance, I got this water bottle right here, okay? The water in here is 64 ounces. Let's assume this is an air molecule and it is full of water. So that's 100% relative humidity, 100% saturated. Can't hold any more water, okay? Now, if I had a larger, let's say a 128 container, all right, let's say that's a bigger air molecule, and I poured the water out of here, just pour the water on the floor. I pour the water out of here into the larger one, okay? Now I have more volume, but the same quantity of water. So in the full container, that's 100% relative humidity. But in the second one, that's only half full of water, it's 50% relative humidity. But it's the exact same moisture content. This is the difference between wet bulb and relative humidity, okay? The moisture content in the air stays the same, but as you warm the air up, the air gets bigger. It can hold more moisture. So relative humidity drops because relative humidity is how much moisture is in the air relative to its cubic size. As we cool the air down, we now shrink it back. So now let's just say I got the same one here and I don't spill it on the floor in my example. And I got a 32 ounce container. So I've now shrunk the volume. And if I try to pour all that water in there, what's gonna happen? It's gonna overflow. Well, that's what happens whenever we take an air molecule and we start to cool it down. It's like taking a rag that's partially wet, but as we squish that rag down, eventually we're going to get it to where we'll wring the water out of it. Well, as we cool the air down, we start squishing that molecules of water that's in the air closer and closer together, and then finally we will reduce the volume of the air so that it can only hold the amount of water that's in there. And then if we cool it down any further, we squish the water out. So, hope that helps. So, moisture content is not relative humidity. Relative humidity is the amount of moisture in the air compared to its volume. And that's how we get the water out of the air. We cool the warm, moist air across the evaporator coil, and as we cool it down, it's going to reach what's called dew point, which is the temperature in which the water condenses out of the air into a liquid and goes out. So if you measure the relative humidity across an evaporator coil, you'll notice the relative humidity goes up. And that's because we reduce the size of the air, but the moisture content goes down. How about that? Wet bulb drops across the evaporator coil, relative humidity goes up. The air on the other side is now a very small, 100% saturated air molecule. All right, think about it. Take care.